Hey guys, my name's Marcel Coetzee. I'm from South Africa.
South Africa, I guess I will put the map here.
I'm a consultant. I'm a data engineering and AI consultant, and I run a company called MoonCoon. We skip the personal computer. In most cases, actually, the majority of Africa, most people only have cell phones. The desktop computer, we kind of skip that.
Okay.
That phase, almost no one had a desktop computer in the 90s. Internet data is extremely expensive. We're one of the most expensive countries in the world when it comes to the price of mobile data. Roaming data, it's unbelievably expensive. But you won't find people watching videos on a bus.
What's your impression with Spark streaming in general?
I'd say it does the job. What I don't like about it is the JVM, right? Which really demands a lot from the end because now it demands that you are familiar with the JVM before you can even start doing your job. And not all data engineers want to know Java or want to write Scala code.
Welcome to the new episode of Streaming Caffeine. This is Jove, and today we have a very special guest, not coming from North America, not from Europe, Marcel. And actually, we have a lot of discussion linking our different Discord or Slack. He's very active on different channels. But I let Marcel to review and where he is and what you do. Yeah, go ahead, Marcel.
Sure. Okay. Hey guys, thanks for having me on. My name's Marcel Coetzee. I'm from South Africa, born and bred. I'm sure we've been in the news a lot of things recently. One of them isn't data engineering or databases, but we have a functioning economy here, and we also apply these technologies to our. And I'm a consultant. I'm a data engineering and AI consultant, and I run a company called MoonCoon, and we take on projects from stock standard data engineering workloads or deployments to more flavor of the day analytical projects like LLM deployments, inference, and so on.
Yeah, South Africa, I guess I will put the map here. For people who, I mean, including me, we are not that familiar with the technology landscape in South America. In that, I mean, in some cases, people might moving so fast they skip a certain phase. For example, in Canada, for example, bank people still use check and draft, right? But in many places in Asia, people even skip the credit card. They just do the QR code scanning, even separate crypto things like that. So I'm not sure in your case, South America, Africa, is that like 5 years, 7 years behind, or even you guys skip a certain phase and even ahead of Europe or North America?
Yes, so if I'd say we're definitely not ahead of first world countries. We still have third world country, very much so. And these phenomena also occur in our country where we skip the personal computer. In most cases, actually, the majority of Africa, most people only have cell phones, mainly because of poverty, but also because of poor distribution. And computer hardware is actually pretty expensive here, very much so. I think we pay like a good, I don't know about the exact percentage, but it's a good 40-50% premium on what, let's say, the Americans would pay for hardware manufactured in your country. So yes, we do. So what people here do is they only have a cell phone, and a very good cell phone, like actually quite expensive cell phones. They'll have the latest iPhones or Samsung Galaxies, but you'll rarely find the common man to have a laptop or desktop computer. It really is only the middle class and up that have desktops at home. And obviously businesses have servers. But yeah, it's not the desktop computer. We kind of skipped that.
Okay.
That phase. Almost no one had a desktop computer in the 90s, right?
So when you ask someone to use a service, register somewhere, you cannot expect they open like Safari or Firefox. They just use the mobile phone, mobile browser, mobile app. Okay.
Yeah,
and
so,
how's the internet? Is that fast and cheap?
Yes. So no, internet data is extremely expensive. We're one of the most expensive countries in the world when it comes to the price of mobile data. Roaming data, it's unbelievably expensive. To the point where people go out of their way to first find a Wi-Fi hotspot to use to be able to call someone, let's say, on a service like WhatsApp. The itself is somewhat affordable, and I wouldn't say it's terribly slow. I think I'm running on a 150 megabyte line. So it's not, so we do have okay internet, but mobile data, that's just like if you leave your house, you pay unbelievable prices for the data. So you tend to use and only call when you're inside your own residence or at some building with his wife.
So do you think that will impact some of the consumer-based or business-based software solutions? For example, I'm coming from China, right, or maybe in Japan, the data is relatively fast and cheap, right? So people, for example, on the street, they use the phone. On the bus, they watch a lot of videos, TikTok, something like that, and then they
Yes,
order
yeah.
pizza, they order Uber or something like that. In South America, sorry, in Africa, if people need a certain Wi-Fi, but they use the mobile device, that generates a lot of uh, on-demand order from the mobile phone on the street or something like that.
So, okay, so people order from a mobile phone, right? That doesn't take that much data, but you won't find people watching videos on a bus.
Okay.
You're streaming videos on YouTube or whatever. It just takes too much data. It's too expensive. Unless they are very wealthy.
Okay, interesting.
The lower class tends not to do that. And our countries are the wealth distribution is very unequal in our country. So like 1% of the population pays like 80% of the tax. It's crazy. You have a small wealthy population and a very large impoverished population. The impoverished population, which is good 40, 50 million, no, more than 50 million people, they don't have the luxuries, probably not basic luxuries, but they don't have unlimited Wi-Fi necessarily. They'll get that at their place of residence, at their work. Actually, they'll use the Wi-Fi, or they'll use the Wi-Fi at their maybe library.
Okay.
So yes, we are obviously modernizing. So as we speak, there are initiatives by the government to put in some Wi-Fi hotspots at public locations, but it does remain a very impoverished and corrupt country.
Okay. Yeah, so we're not going to go into detail about that, but I guess there's problem everywhere in every single country. And so this can be a challenge, a bottleneck, but also opportunity. Right? So I guess the
Yes.
telecom or those consumer-based internet we call O2O, the online to offline, those things can be a huge opportunity
Absolutely.
in South Africa. But regarding the enterprise or bank, those corporates, do you think maybe compared to Europe or North America, anything different?
Yes. So with the corporate and enterprise institutions, there's no real difference, really. I'd say with European companies or even American, because the money's there, right? The infrastructure, there's enough money to bring all the required infrastructure together to operate these entities. For example, our banks here, we have, on-premise data centers, we have co-located data centers, we have an AWS and GCP data centers in our country. It's not like, if you don't have the money, you can't use these modern services, right?
Mm.
Yeah, but obviously, it's so all those amenities are there. However, there is one difference when it comes to these cutting edge chips. I know this is a data engineering podcast, right? But since I also operate in the AI space, let's say the NVIDIA H100, right? It's the new hottest thing, or H200. You won't find. I don't think you'll find a single chip in South Africa. Why? They're all in the US, and it's very hard to get. I think impossible even to get one into our country. You won't find those distribution networks. We do operate on all the on all the chips in general. So we don't have the latest and greatest models of CPUs, GPUs, and so forth. But it's a year behind at most. Like, it's not like that bad. It's like maybe 8 months, 6 months. And we don't have the talent in this country to utilize those chips anyway. So the talent in South Africa is still it's not like we have the best data engineers in the world. They're good enough to do the job, but I won't say like they are the top 100 in the world or anything, or top 1,000.
Okay.
So,
Yeah, regarding the AI chips, I guess with this new president position, American first, right? So I guess it's very common for any country except America. They all have the challenge to get the latest chips, AI chips.
Absolutely. Yeah. And there's a geopolitical reason as well. South Africa is aligning itself with the East. Yeah, America won't send any H200 chips our way anytime soon, I think.
Okay. And for the data engineering you mentioned the consumer, they don't, they almost skip the laptop or the PC at the home
Yeah,
space.
the desktop computer era wasn't really a thing. Yeah, people just went
Okay.
straight to laptops, right? And then it's only a few people who own laptops, a small
Okay.
percentage. Yeah.
Yeah.
So
So
90% of the population have phones, the rest have laptops.
yeah. Okay. Cool. So for the data center or like enterprise software or deployment in South Africa, for example, do you guys also skip like Oracle, Teradata, those heavy solution, go directly to like data lake or like Iceberg directly? Can you share more about something like that?
That's a good question. So, a lot of these things happened in the 2000s and 90s. I was still like in school. When you're talking about big iron, like the big rack servers that you buy as a product, where the hardware and the software is tightly coupled. That was certainly a thing. Yeah. We did not skip that. For example, one of the projects I was involved in when I was at Nedbank, which is one of my, I was employee there, like maybe half a decade ago or so, a little bit more than that. No, 7 years ago or so. And we still ran our analytical queries on IBM Netezza, which is a big distributed data processing cluster and it's proprietary hardware that you would actually just, it's an OLAP DB that you buy, but you don't buy the software. You actually buy the rack server and it's delivered.
It's all in one machine with the
It's
hardware
an
and software
all-in-one
network.
machine. Yes.
It can be
And you
very, very
sign like a year
expensive.
contract for like, I think it's a lot. It's like $10 million or some crazy price, right? And imagine you're South Africa, so that inflate that by another 50%. Yeah, but the banks that have that, and now they are in the process of migrating to cloud. It was a big theme in the South African IT space. Maybe not today so much, but certainly I'd say 5 years ago, going to cloud was everything. Everything was going to the cloud, including the data lakes and the analytical processing engines.
5 years ago, everyone, we need to move to the cloud in the future. Now, there's a lot of discussion. Some of the cloud service is not expensive, it's not cheap, right? And people want to use the old data center. And is that a trend going off, or people just swing around?
Yes. So even that's a trend as we speak. People are realizing that ultimately just pay for someone else's server. You might as well just run it yourself if you have, if you're brave enough to do it. And now people are doing it. I'm starting to bring a lot of things on premises. Now that you mention it, actually, theme I've seen locally. I don't know how much of a local phenomenon this is, but in South Africa, people are moving, are actually starting to build entire data centers, call it on-premises data centers with commodity hardware. So they won't use AWS, they'll install like a hypervisor Proxmox over like literally a bunch of machines. And then on that install a data orchestrator, install the object storage, and have their own on-premises cloud that they can use for their analytical workloads. So that is quite an interesting phenomenon. Use these homegrown data engineering labs, if you will, for these like smaller companies, like I'd say mid-sized companies.
Yeah, so thank you for sharing all those interesting observation and thoughts regarding the difference every country, every location have their own unique scenario patterns or paths about how they get there. Myself, so you've been working on data engineering for quite a long time. Can you share a little bit about your recent project or something you want to this is quite interesting and I want to share it to the rest of the world if that's not too sensitive?
Yeah, sure. So today, I operate as a consultant. I can't mention necessarily all my clients, but I'd say some of the more interesting projects I've actually been involved in, we'd have to go a bit back. When I was a full-time employee at a bank I actually worked at two banks, one of them being Nedbank, and the other one being one I can't necessarily mention because that was a consulting project. But I'll start with the one at Nedbank where I did so Nedbank is it's a local a retail bank. They also have some commercial operations, but I work on the retail side. I was part of the advanced analytics team and that was a group of 20 odd people with STEM degrees. And, we were tasked to run our analytical or rather design models to fit on the data and then utilize the on-premises OLAP DBs, SQL and such to actually test our models and ultimately deploy them. Now, none of it was as seamless as it might sound at first, because the BI teams and some of the IT teams weren't necessarily, always geared to help us out. So, sometimes we had to really go low level and, even deploy things on Kubernetes clusters just to get our product to market.
So let me pause a little bit because there's some background right now on your side. Yeah, that'd be great. Yeah, thanks so much. Yeah.
Okay, Joe, cool. Are you ready?
Yeah, nice. So cool, nice. So what kind of a particular challenge in that kind of data projects?
Sorry, didn't catch you there.
Yeah. Cool. So what kind of particular challenge in such a data project?
So the challenge is that we didn't always have we didn't really have access to data engineer, like a proper data engineers back then. So my title wasn't data engineer. My title was data scientist, because there's no data engineer to actually construct all your features for you, right? Or to construct these data marts, as it's known, that you can operate on. We had to play the data engineering role ourselves as well. And that was quite challenging, because now your title is data scientist, but now you have to become a data engineer in real time. And hence you find yourself writing Spark code just to be able to parallelize your algorithms or your feature construction code or ETL code, so that you can fit on all the big volume of data that you have, right? So there's this data processing library called Pandas that quickly breaks down in this space, because it's nice with 1,000 rows. It doesn't really work with 1 billion rows anymore, and 1 billion rows is a small data set in a bank, right? So then you had to actually learn these data engineering workflows yourself, right? And it was it was fun. Like, that's actually where I realized I actually like being a data engineer, because I was actually tasked to scale the team's analytical code, because they would write it using common stock standard PyData code, as it's known, right? So Pandas scikit-learn, first do your data processing using Pandas. You scikit-learn to fit your linear or nonlinear algorithms, or even something like XGBoost if it's decision trees, and do your POC or deploy them. However, you have to fit them on data that's more than just some, more than what a single machine can handle. You find yourself having to fit algorithms or train on data or do data processing that's out of core, and that's where I would start coming in and actually scale the team's code. So I would actually go to the Netezza cluster and then start building or constructing these math that we can use myself.
Okay, cool. So you mentioned different roles. So even today, like on average, regarding typical to do things on data engineering, like ETL, those are database setup, those are modeling, and also data scientists on the algorithm, or even on the visualization BI things. I mean, how you allocate time, your bandwidth by yourself on different roles? Like how much on ETL, how much on the data scientist algorithm, ML stuff?
Oh, yes. Yeah, we did take a divide and conquer approach there. Let's say so the whole team would be assigned, let's say 10 projects at a time, and then we'd split into standing teams of or smaller teams of 4 or 3, and there'd be a team lead within those 3 data scientists. Hence, then I was just asked, Marcel, since you're so good at this, since you're so good at scaling our code, right, which is data engineering, but the team didn't really have an apt term to put to it. They just asked me to kind of do it full time. So I would actually jump between the different teams, look at their code and see where it doesn't scale, and then take it and tie it to production data sets. And then that would just, given the constraints of the organization, of course. So like we had a Hadoop cluster, but the Hadoop cluster didn't necessarily always work. And when it worked, you really had to know what you were doing to be able to use it properly.
Okay. So you mentioned some proprietary IBM software hardware as OLAP. You mentioned Hadoop, Spark, Pandas. Any projects have a strong requirement, business requirement regarding low latency, high throughput, or stream processing recently in your project, in your clients?
Yes. So I'm not at NetBank. This is now later when I started doing freelancing. One of my clients was another South African bank. So this way I can't mention the name now, but they are actually bigger than NetBank. So they had more capability as well in terms of their data engineering and teams. There are a lot of consultants on there. Not just from South Africa, but across the world. And they used AWS as their cloud. And there were a lot of things happening there that I was involved on. One was migrating data from on-premise Oracle DBs to Redshift clusters, so to object storage. But the one that I'd like to touch on is this streaming analytics project that I was involved on, where we did fraud detect. I was helping with fraud detection, real-time fraud detection, before a payment got approved, or rather authorized. So in this case, the bank, being issuer, didn't want their clients to get scammed, basically, or to be defrauded. So they decided to ask a data science team to look at it, design algorithms, and then where I got involved is I would take those algorithms and actually put them between the payment processor and the bank's APIs. The data scientists' algorithms would pick up a fraudulent transaction, a stop order would be dispatched to the payment gateway to stop the transaction from being authorized. And the way we did that is by using Spark streaming. We would analyze these windows of all transactions coming in, or rather all transactions being queued to send to the payment processor, and do inference on these mini batches. And then if any line item, or rather any transaction flagged a rule, a fraudulent rule, or if it was out of distribution for this particular client of the bank, it would then not be sent to the payment processor to be authorized. It would actually just be withheld, and the customer would be sent an SMS to alert them that there's suspicious activity on their bank account.
And what's your impression with Spark streaming in general?
I'd say it does the job. What I don't like about it is the JVM, right, which really demands a lot from the end, because now it demands that you are familiar with the JVM before you can even start doing your job. And not all data engineers want to know Java or want to write Scala code. Let's say you were trained using Python, and now suddenly you have to go, well, what's this funny exception here? Oh, it's coming from the JVM, and you don't understand what you're looking at. So it's not something I would use today. This was a couple of years back. I'd rather use something like Timeplus, but Spark, it did the job. It was just painful to set up, very painful to set up.
Cool. Yeah. I know it's not just about the JVM itself, right? I mean, for example, like Spark, they have those executor, driver, reserved space, how to spell to the disk. Compared to the regular JVM app, it's much more than that, and be 5x, 10x more complicated regarding how to tune it, right? Again, I even have a recent experiment that is processor data using Spark. I mean, while 2 gigabytes, okay, even more, you have to be very careful to tune the settings, and it's not easy at all. Even for me, my name is Jove. I love Java like 10 or 20 years ago, but I still need to read a lot of documents and case study, see how can work around that OOM issues.
Yeah, no, and for a relatively junior for a relatively junior data engineer who is not familiar with Java, is a non-starter almost. And that's where Spark kind of falls flat for me, because it demands the end user to be very experienced. So you can only start using it when you're extremely experienced. There's no easy way to start it, right? Because you can't just, I guess they're working to make it easier, but just to install Spark itself, you need like 10 components, right? You need the JDK, or you need you need to be able to know how to set up your cluster. It's so much configuration and mental processing to understand how to configure that by the time you're ready to write your code, you're already exhausted. And then you haven't even gone to production.
Yeah, so you need a team, right? A team for the infra, the team for the JVM tuning, for the setup, data engineer, ETL, and also a separate group regarding how to write algorithm using Python, and have an entire army to make things work. And in many ways, even Spark is already way more easy to use compared to the Apache Flink, right? So I mean, those are very, very powerful. People saying we use like 4-digit or 5-digit core for Spark or Flink. They are very proud of that huge machine cluster. But for average team, average company business, it's still a headache to set up a meaningful Spark or Flink cluster to do the thing right.
No, absolutely. And going back to the start of our discussion, especially if you're in a in a skill, especially like if you're in a country where skills aren't as abundant, it can be hard to find like where are you going to find a Spark expert? Even if you manage to find them, they like, there's like 3 of them in the country. So you are forced to set it up yourself if you want it, else you're just not getting it. So there's a lot of tinkering happening in these like more third world countries with these things, where you'll find one person doing 10 things simply because they have to.
Yeah, they are not cheap, and also they are not that stable, right? Because they can go anywhere, right? Because they have a unique skill, and every company wants to do something large scale, and they are recruiting those such a talent with a good Spark or Flink experience. Yeah, I mean, you also mentioned Timeplus. I mean, I remember you joined our user group maybe at the very beginning, like 2-3 years ago, and you also mentioned that you really enjoy having something easy to set up like Timeplus. So, do you mind sharing a little bit about your other feedback or impression about Timeplus?
Yes. What I absolutely loved about it is the quick feedback and easy setup, especially the managed offering, where you really can just point to a data set and see the real-time results kind of in line as it's materialized. And that's immensely powerful because it allows you to develop with in an immediate feedback loop, which makes writing analytical queries much quicker. So I'd highly advise, as a previous data scientist and as someone who comes more from the analytical world than the engineering world, if someone has a fraud detection case in a bank or maybe some other financial institution where it'll take a lot of configuration and effort to be able to set up these real-time data streaming engines, do look at Timeplus. It'll actually make your life much easier, because just the ease of configurability, the real-time feedback loop, and just how robust it is. There's not really, you can get started very quickly writing the queries instead of just being encumbered in configuration. That's what I'd say is the biggest standout for me.
Yeah, so again, we have a different way to deploy, right? I mean, the cloud is one, but people usually just set up some server, no matter bare metal or EC2 or Kubernetes, and deploy Timeplus as a single node or as a multi-node cluster, or even we can have a multiple cluster talk to each other. And there's no JVM. It's basically like unzip and run. And we have some UI for you, as I mentioned, that is you can use some notebook experience that you can visualize the data lineage. And the experience is quite different. For example, for Flink, you might have to write some code, create a jar file, submit to the jar, and wait for the schedule. But for the case of Timeplus, you just write ad hoc streaming query and click the button, you will see the result in the next second, right? So you don't have to send to the other data warehouse to query it. So the agile way to build your streaming pipeline, I guess, is very important for you to explore different ideas without too heavy workflow.
And if I can ask, Jove, have you find some of your users coming from Spark streaming and having Timeplus be a good substitute? Have you seen this before?
Yes, we actually have quite some user and customers. Spark DB, it has been there for quite a long time. They might not be the best, but it's very common. The people just say this is the status code, and it's very common to use it. And why not we use it? But the pain is still there, right? It's heavy. I mean, the people who really know it, it's not a lot on the market. And also the infrastructure costs, how you troubleshoot it, how you understand, for example, the state. I know there are some companies even build a solution to give you better understanding about what's the state in Flink, visualize it, turn that RocksDB state as a more understandable format. There are certain issues there. So there are quite some users, they are passionate to try Timeplus to minimize their efforts to maintain the Flink cluster and also to just experiment different ideas quicker, right? So not have to plan this, write a document, write a different thing to implement. They can just do it in a more ad hoc and on-demand way in Timeplus. So the time to value, how to validate your idea is very key, especially today. There are so many policy change, there are so many different patterns, and something we expected to change the system for 1 quarter. Right now, you might get ask from your manager to do this within 2 weeks. So how you can set up something very quickly and also have some working code to validate your idea and to iterate to improve performance and accuracy. I think that's a common theme for like modern software, right? It's not always about like large scale. It's not always about high performance or latency. I mean, how to improve the developer experience and how to make this or everything version controlled and shareable to others, and even vendor agnostic. You can have some similar thing run in different engine. I guess that's also I know in North America and in many of the world, people started to pay a lot of attention to Iceberg, those open formats, right? And vendor from AWS, vendor from Databricks, they might come with a very good implementation, but they are all based on a common understanding about how the file should be, how the metadata should be. So if you enjoy the managed service from AWS, yeah, you can do it. But in theory, you can move the data or even try some other engine without move the data, right? So this can create a healthy competition among the vendors, and also for small company, they can innovate fast because they don't have. They can just, hey, I can do Iceberg query 5x faster. Then you can reuse your existing data just to try different engines. So this creates a room for either smaller company like us. But again, I guess people have to balance regarding what's the mainstream technology, what's the cutting edge stuff, what's the open format, what's your business like support level. Do you want to have someone to be like contact within 1 or 2 hours, or it's okay for you to submit a GitHub ticket and wait for 1 or 2 months? Right? So there's a lot of factor you have to consider when you choose a data stack or put different things together. But there's a lot of options today, I guess, more than we had before.
That's interesting. Would you say that maybe you can enlighten me, because I find it's very interesting. Iceberg, how well does a streaming engine play with the Iceberg format? Because I don't think that's something that I have touched on as yet. I haven't, and doing the streaming analytics consulting, I haven't actually used the Iceberg format with a streaming engine. So I'd love for you to tell me how that, what the state of affairs is in that case.
Yeah, sure. So again, when people say real time and streaming, actually, they might have some own bias and context, right? So for example, when we talk to some financial trading company or separate crypto company, they are talking about real time or streaming at not just a sub-second, but they're also talking about the single-digit millisecond stuff. I guess in many cases of streaming for Iceberg or data warehouse, we are more talking about 1 or 2 minutes or even 5 minutes, but it's still considering to be fast enough. For example, our friend in Verberica or Flink community, they have this idea called streaming house. By combining streaming and data warehouse, it is a streaming house. The projects such as Apache Spark, they have leveraged some Flink technology and also have new Flux storage. So there's some work regarding how to combine streaming technology with data warehouse. And also Iceberg also supports OK streaming injection. But again, we are not talking about second level or sub-second level, but compared to just put the data in S3 and query those S3 file using Trino, Iceberg provides a much better mechanism for you to describe how you want to send data in, how different organization worker to merge the small file to a bigger file, right? And how to even build some index, and you can build some snapshot for you to go back to a certain version, something like time traveling. But again, people choose Iceberg not really for some workload from, for example, Confluent or Kafka, right? So there's still a need for you to use Kafka directly using Flink, using Timeplus Spark to get the real-time, for example, fraud detection in the second level, right? But you can continuously move the data from Kafka to Iceberg. So the data also can be queried using Trino or Athena or Spark in the next 2-3 minutes, visualized in a dashboard. So different data with different freshness will be in different systems. They will eventually they will be all in Iceberg. Iceberg can be the long-term storage, but if you really care about the like second level low latency alerts, you still needed to deploy something for like Flink or Timeplus. But Iceberg seems to be a very good regarding cheap and reliable compute and storage layer. and you can use different tools you like to query it. There's no really a vendor law.
That's interesting. That's
Yeah, and I
interesting.
also see some of the work to do incremental read or even something like CDC for the Iceberg context. But again, it's not really an easy problem, right? We see CDC is very common for OLTP, like Postgres or MySQL, but it's not that common to have a CDC for OLAP. Essentially, Iceberg is an OLAP. Right? With so many high volume data, how to do the CDC meaningfully. So I guess people more at least care about if can I do incremental read for the Iceberg table, right? For example, last time I read this 10 million rows, can I read the next 1 million rows without repeat reading everything? So I think that's initial requirements. But step by step, people will be asking whether a certain dimension is changed. Can I update everything in Iceberg? Can I do some incremental updates to reflect my BI reports? Again, not saying people reinvented the wheel, but there's always a new way to do things, right? In the past, we have a lot of disk. Now people are very passionate about S3, and people talk concerned about cross-region or cross-AZ expand kind of a cost. But S3, they have the built-in cross-AZ, so you don't have to pay for that. So people have a strong preference to use more S3 as their cloud disk. Now people have to move the solution. For example, CliffHouse, we are very familiar with CliffHouse. It's very optimized for the local disk because once you buy a local disk, you can send unlimited IOP, huge amount of update on it because it does cost nothing. You already pay for the disk. But for the case of S3, the more API call, the more expensive you get, right? So you have to be very conscious regarding how many API call you should be doing. For example, the file size, you should not really create too small files, like maybe like 400 megabyte or more might be better for a regular file. S. Even we are just talking about move the storage from local disk to S3. There's a lot of fundamental principle changed how you design the application, right? So that keeps all the vendors, including Timeplus, very busy. But for the data engineer, you guys have more options, right? So for some time-sensitive throughput or time-sensitive application, you might want to deploy locally. If 1 or 2 minutes or even 5 minutes delay is okay, maybe Iceberg can be a solution. And if you care about single source of truth, yeah, maybe Iceberg is great, or multi-engine support. It looks very promising. And Iceberg is not the only one, right? Hoodie, data table, even on the catalog world, there's a lot of different vendors. People really want to move fast to put themselves in a better position for the future.
Yes.
For the next data engineering for the next few years.
Sure. Yeah, that's it's hard to appreciate the complexity if you don't really read into it. And what I find interesting is how do you, as Timeplus, how do you choose between, or how do you make the decision between which table formats to support? Because you could have dedicated your time to build support for Hoodie as well. I wonder what drove that decision.
Yeah, in short, that is supporting or embrace Iceberg or Data Lake is it's more like something we cannot ignore, but it's still more like a side track because we cannot do everything so well with our current scale, right? I mean, we are not Databricks, that's for sure. So we cannot do everything. Campus, our principle, or as you mentioned, there's people what kind of thing they think about Campus, it's simplicity. And it's very powerful and it's developer friendly. So we still invest a lot regarding how you can deploy Timeplus in your local center without any cloud dependency. You can run everything very fast using your local disk. But when people have multiple terabyte or even terabyte data, it's not a good idea to put everything in a local disk, especially you have to consider some replication factor, right? So you don't want any data loss. Using S3 tier storage using Iceberg is very natural, and we have to support that. But in many cases, Plus is built for real-time processing or real-time ETL. And we use our local disk as our primary or recommended solution. People, if they want to use something like Iceberg, it's not too hard for us to export that. But for example, we right now focusing on how to write data to Iceberg in the streaming way. For example, if you data in in your Kafka, in your Apache Pulsar, or in some other IoT sensors. You can collect them using Timeplus or using Timeplus to move data from Kafka to Iceberg in the real-time way. But we leave the heavy-duty S3 file consolidation or compaction to the vendor. Like for example, Amazon, they also have this service from S3 table. And if you use Spark or Flink or even other vendors such as Startup, they have some solution for that. So they can keep refining the file on S3 to merge the small file to bigger file to have a better index. And you can use them as a query engine. Timeplus, we do the basic query today, but we're more focusing on the write because that's the beauty of Iceberg ecosystem. That is, they have so many different components, and you don't have to do everything by yourself, or maybe you should not do everything by yourself because that's defeat the purpose of multi-engines. Our role is to move data from a streaming platform to Iceberg, and you can choose your own storage, you can choose your own query engine and the government or role-based access control. But we play our role to making sure the data will be arrived in Iceberg in a relatively real-time way. Cool. Yeah. Again, yes, and we're looking forward to see more feedback from you guys if you can try Timeplus in some of your data projects, and also like the Iceberg there's a lot of new nuances for the data engineering side. I think you are very active on LinkedIn and all other community. I guess you don't really like invest time on LinkedIn just for like find your potential client, right? So I guess it's more for the learning purpose, I guess.
Yes, it is certainly to keep a tab on what's happening in the field of both data engineering as well as the AI space. A lot of the eminent people in both these fields do post quite regularly, and it's nice to click on one of their posts or to see a new paper released by Meta within the AI or data engineering space. And people like Jan LeCun that I follow, they're very active on LinkedIn. He's one of the Turing Award winners because of his work in neural networks. So, these people are on LinkedIn. So, what they, it's not like they go on LinkedIn to write subpar content. There's still quality content there. Otherwise, I'd say it's a good recruiting platform, especially if you're a consulting agency like MoonCoon. It's pricey, but you do get good talent by going through that platform to hire someone. And I'd say overall it's a useful platform if you use it right. I think if you go on LinkedIn and you just keep scrolling, you're really just using another TikTok, right? I don't think it's that great for your time, but if you are focused on what you're doing on the platform, there's valuable things to be gained.
Yeah. Every platform can be a learning platform. So I'm not saying the word, but there's some adult video platform. People even put some ML learning stuff, but also linking, you can write a relatively longer post compared to X. And also you can have some image, you can video. If you want, you can write a newsletter with multiple image. And then you mentioned that there's a lot of famous guy active and sharing their thoughts on LinkedIn. So it's always a great platform for you to be relatively focused on a certain domain and go to that social channel. Cool. So, it's so great to have this conversation. It's longer than expected, but so much fun. I'm sure. I hope when I share this, there's a lot of, it will be level with many other audience in our group, our friends. Any last thought that is, what do you think, like, what will be happening next year, same time? Any regarding data engineering, do you have some big bet on certain technology or certain trend?
That's a good question. The elephant in the room with these data engineering conversations always tend to be DuckDB for some reason. I'm sure because it's the hottest technology and it has been for maybe a year or two now in this space. One would wonder, I'd wager that there will be a company who would, I'm sure there's already a couple of them, who would leverage the DuckDB engine to actually create a streaming layer. Because I'd be surprised if someone hasn't done it already. One could argue if it really is as great as people make it to be. But the amount of money thrown at the DuckDB ecosystem is certainly far from drying up as yet. So I'd say there's some things to come from that space. That's what I'd say.
Yeah. DuckDB is a very unique. Yeah, it's even to some degree it's related to how OpenAI is meant to be. DuckDB itself is a non-profit organization, and Maladuck is the other company. They somehow have some deal to use that technology, but commercialize it on the cloud. And I think the recent some new features such as DuckDB UI actually is contributed by that Maladuck, but it's not, the code is not in the DuckDB. I guess when you start the UI extension, they will download some code from Maladuck repository or some CDN to have the UI. So the code ownership still belongs to Maladuck, but it's part of the DuckDB experience. Yeah. So, and also I saw some, yeah, it's always a very difficult balance. I mean, Timeplus, we have an open source project, but still need to find a meaningful way to find the right person to sell our enterprise offering. And I guess this also applies to Maladuck and the DuckDB. When you have the DuckDB/UI, you have a very nice interface. It's also a way for you to sign up Maladuck and try more premium service over there. But it's always a balance. And also, you mentioned whether there's some project to leverage DuckDB as the base for the streaming processing. I already see one or two projects already, but again, it's DuckDB is something you cannot ignore. It's more than OLAP, right? You can do some meaningful ETL using DuckDB, and they are put out effort to make this everything easy to use, very powerful, very fast. Yeah, and so far, I guess people enjoy using DuckDB and let it be. And I think the world should need such kind of competition, right? So there's no clear winner. Everyone have to work super hard to make the developer or data engineer happy. And good luck if you can find a way to earn money. Maybe people who in Europe, the team behind the DuckDB, they are not really big fan of earning a lot of money, right? They just enjoy building a fast, easy to use system. Yeah. I hope. Yeah, cool. Yeah, I hope in your country, South Africa, Maladuck, in your let me do that. So I hope in your country, Africa, DuckDB, Iceberg, stream processing, or Timeplus will get more popular, and we can schedule the other call the other day to share more progress. Maybe we can do the same. You can do this in the same time next year, and looking forward to chat you again. Yeah, thank you everyone. And that's the end of this episode of Stream Caffeine. Again, this is a podcast for us to talk more about data engineering, to talk about the streaming processing. And if you think it's valuable, feel free to subscribe or share with others. And if you have something insight to share, just as Marcel, and feel free to contact me. And happy to put you as a guest for the next episode. Thank you, everyone. Goodbye.